Spagnola.
I'm Aashka Patel.
I'm Caroline Dowell-Esquivel.
And we have a question for you. So, how many of you have ever experienced a broken heart? Symptoms include stress eating, watching an insane amount of romantic movies, and feeling like an absolute failure. And I wish I could stand here and tell you that the Cardiolevenator is the cure for the broken heart, but I think instead we're going to focus on the failure aspect. We'll keep you posted. Heart failure, or end-stage heart failure in particular, is when the blood cannot flow through the heart because of a structural or functional cardiac disorder that impairs the ability of the ventricle to fill or eject blood. And it proceeds to an end-stage state when conventional heart therapies or symptom management strategies no longer work. And the patient could experience symptoms of rest, and in addition to while doing exertion. So I've actually undertaken research to decide which treatment would be the best to treat end-stage heart failure. And while there's many options, including medical management and heart transplantation, the one that we found is left ventricular assist devices. The name sounds a little bit complicated, but basically it's a device that assists the left ventricle in pumping blood throughout the body. Explain were 2 out of the 3 different ways that you can use a left ventricular assist device, or an LVAD. And the first, and the one that we're going to focus on today, is destination therapy, and I'll explain that in the next slide. But just for your information, a bridge to transplant exists when you implant a left ventricular assist device into the patient's heart, and it's there to support them until they're able to get a heart from the donor transplant list. And also, a bridge to recovery exists in some rare cases, and especially in young, active people, where you implant a left ventricular assist device and the left ventricle is able to actually recover its normal function, and you can explant it, and then the patient can go back to living their normal life. So there's actually some problems with left ventricular assist devices that we decided to improve upon. Destination therapy is a treatment that you would implant into a left ventricular assist device into a person that would only have a finite amount of years left to live. So it could happen 5 years, 10 years. It's a treatment, you know that they're not going to survive after the left ventricular assist device. And this is the area that we really chose to focus on to make improvements in this field, because the Cardiolevenator that we designed, it'll provide support to people that don't have any other option. So the way that it would be dispensed is using Microchip technology. It's actually a new innovation that's been developed by researchers at MIT. And what the Microchip is able to do is have a storage of myostatin, or technically any medicine, but we would be using myostatin. And it would dispense set doses, which would be set by the doctor and could be altered periodically over time. And it would be dispensed to the body, and it would be injected into the left ventricle. Okay, so there may be some confusion because I know a lot of people are familiar with beta blockers, which is a current treatment for people with heart failure. But the difference between a beta blocker and myostatin is that beta blockers actually allow the heart to pump slowly, and this would eventually lead to lower blood pressure. But the difference with myostatin is it wouldn't allow the heart to pump slowly. It would still pump just as quickly with just as much efficacy, but it would inhibit the result. It's kind of like when you're working out at the gym and you're lifting weights and your muscle is growing. What it would do is you would still be allowed to use the muscle just as much, but it wouldn't lead to the muscle growth, which would then restrict the blood flow. So before our development could be set out on the market, we would definitely want to run some experiments and some trials. And something that we found through our research is that hypertrophic cardiomyopathy is like the #1 most prevalent cardiac disease in cats. And the interesting thing about cats is that their heart is structurally very similar to that of a human, except it's scaled down in size. So what we decided we could do is take our Cardiolevenator and scale it down to the size of a cat, and then we could find veterinarians across the country or in a localized region, and we could have pet owners enroll their cats in this clinical trial to hopefully save their cat's life and improve their quality of life. We would monitor the progress over a course of however many years we decided, and eventually, hopefully, come up with a show of the effectiveness and the safety of this before we would take it to human trial. So we would have to monitor controls of the cat and like what their diet and the age, but overall this is the experiment that we would design in order to make this a reality, and hopefully we actually will be able to make this a reality in the near future. So, thank you.
So you mentioned, again, it's a destination therapy, but can you comment on, is the quality of life after this has been installed equal to, greater than, less than, as it was before?
So what we're hoping is that with the new invention, what would happen is the blood flow would be expanded more, and that leads to the alleviation of a lot of the symptoms that come with end-stage heart failure in general, but also specifically of hypertrophic cardiomyopathy. So when you have blood that cannot flow through, you're obviously not going to get blood to your extremities. It may be difficult and strenuous to participate in different exercise. So hopefully by alleviating some of these symptoms, people can go out and live their lives. And also there's a lower risk factor for anything horrible from happening, whether it be a heart attack or like sudden cardiac death. That is something that would definitely be prevented by this invention.
Would it have all the years worth of myostatin in it to start?
Yes. So with the microchip technology, it's capable of storing the entire amount of the myostatin that you would need over a set period of time. So it's a destination therapy. So what that means, you would say, okay, you have 10 years to live. Here's all the myostatin that you need, and it's set to program to give out this amount for that period of time.
But then you also realize that doctors can lower the dosage, increase the dosage.
Okay, so it's adjustable as well.
It's
Okay.
adjustable.